All right, so we're talking about Planck's equation. If you were in class yesterday, or the other day, whether it was, I explained this exact problem in class, but I want to make a video to reiterate how we're trying to do this. Yes, this is a harder concept to get, but it's mainly just because we have larger numbers. So what we're going to do is we need to start out with basically stating that Planck's equation says that energy equals Planck's constant times your frequency. Now remember, the frequency is just going to be equal to the speed of a wave divided by its wavelength. So what you're going to do is basically, this means that we are equaling, so E also equals h times the speed of light divided by the wavelength of that wave. So remember, lambda is wavelength. But we also know, according to Einstein's theory of relativity, that E equals mc squared. So in both cases, E is going to equal energy. So we can assume, based on this, that since E equals mc squared and E equals hf, that means that mc squared must also equal your Planck's constant times frequency, which also equals, of course, Planck's constant times the speed of light divided by the wavelength of the wave. Okay, so based on this fact, we can understand that if we are able to find the energy of an object, we can too then find the mass of an object, even if we're talking about a photon. So in this proof, we have to prove that, yes, you have a mass for light. Crazy to talk about, I know, and extremely, extremely small, but it is true. You can calculate the mass of a particular light wave with this formula. Now, remember, E equals energy, H equals Planck's constant, which is 6.63 times 10 to the negative 34th joules times seconds. Remember, that's not going to really matter much because we're just going to find the energy, which is always in joules, and Planck's constant is always the same, so we don't really have to find that. So the speed of light is also a constant, so it is 3.0 times 10 to the 8th, and that's meters per second. Your lambda just represents your wavelength, and your frequency, which is all we have left, well, mass, m equals mass, and that's going to be in kilograms, meters, and then you have your frequency, which is measured in hertz. Okay, so with that being said, if we look at number six on your worksheet says, and I would suggest getting a blank sheet of paper to work on this, because as you're going to be able to tell with this particular worksheet, it's going to take me pretty much this whole page to fill it all out. So with number 6, it says calculate the mass of a green light since it has a frequency of 6.01 times 10 to the 14th. So based on this, we can't do mass right away because we still haven't found the energy. So what we have to do first is we have to find, since we're given the frequency, we're going to use this one instead of this one. Okay, so this is our formula to find the energy of your wave to start with. So if I am multiplying, I'm going to take my constant, which is 6.63 times 10 to the negative 34th, and I'm going to take my frequency, which on your paper says that I have 6.01 times 10 to the 14th. Okay? Now, Remember what I've taught you about exponents. So if we're doing powers of 10 and we are multiplying, so when you multiply, you are adding exponents. And when you divide, you subtract exponents. Okay, so in this case we're multiplying, so we're going to add them together. So I always suggest putting a nice little line there so that we don't worry about it. So whatever this answer is going to be times 10 to the negative 20. Okay, and if we do the math, we're doing 6.63 times 6.01, because we're still going to multiply this side. So it gives us 39.85 times 10 to the 20th. That's not correct because we have to move it over 1. And remember, when we move to the left, we are going to add an exponent. If we move to the right, we are subtracting an exponent. So in this case, we're moving to the left. So we're going to have 3.985 times 10 to the negative 19, and that is joules. Now we are not done. This is only the first part. So now we need to get into the second part. The second part is going to show us how to get our mass. So the nice thing is we have our joules, so we can plug it in, and we also know the speed of light is 3.0 times 10 to the 8th. So we can plug this in. So we have, so this is part 1, and this is part 2. So I have E equals mc squared, so I have 3.985 times 10 to the negative 19. So that is going to equal m, because I don't have a mass, I'm looking for mass, and I have my speed of light, which is 3.0 times 10 to the 8th squared. Now here's another little trick for your, when you do math in the future. You're going to have exponents that are going to be inside of your, so powers of 10, so you're going to have your exponents that are going to be inside parentheses. So you have exponents on the outside of the parentheses and the inside of the parentheses. You multiply them together. So now this is going to be, well, 3 times 3 is 9, so I'm going to have 3.985 times 10 to the negative 19 equals m times 9.0 times 10 to these, and 2 times 8 is going to be 16th. Okay, so now I need to get both sides, get rid of that 9.0 times 10 to the 16th. So I'm going to divide both sides by 9.0 times 10 to the 16th. And remember, so what this means is that we are dividing. So if we go back up here, we see that we have to subtract our exponents. So we're going to subtract. So this gets rid of one another. And now I'm just going to do my division problem. So whatever my answer is, so m is going to equal whatever my answer is. But remember, I'm going to draw my line. I'm going to subtract them, but a negative 19 minus 16 is going to give me times 10 to the negative 35. Now I'm going to take my answer, so 3.985, and then I'm going to divide it by 9 because I'm doing that way. This is going to give me 0.442, or 3 actually, times 10 to the negative 35. Still not true because we got to move it over 1, but remember, if we move to the right, then we're going to take away another exponent. So it is going to be 4.43 times 10 to the negative 36th kilograms, because remember, mass is always in kilograms. So this is my answer for the mass of a green wave. So again, it is a wave. Think about waves. Waves travel through space. Waves travel through people. Waves travel, it's extremely small. So of course the mass is going to be really small. The nice thing is that this is one of your hardest questions, so the rest of them should be pretty easy to figure out. Yes, number 10 is also the mass, but you can figure out everything based on your particular question. So this one encompasses everything. You can cover all of your stuff based on this information right here. All right, the rest of it follows along with this. You just have to figure out which of the formulas you're going to use to figure out the energy. All right, if you have more questions, I suggest asking me on your own time. You can always look up more practice with Planck's equation. That's perfectly fine, but that is your homework. That is one of the 10 questions. So you only have 9 to go. All right. Have a nice day. I hope this doesn't hurt your head too much.